I'll try to address that question. As William described, it's a pretty complex math problem. We have to determine what the genetic relationship is between all the pieces in it. So we have harvest data and the scan data, and we put in how those are correlated. And so the heritability on those traits might be somewhere in the order of 0.3 or so. And then we bring in the genomic piece where the heritability is pushing more towards 1. I mean, the heritability can be 0.9 because you have you're looking at the genotype. You don't have the genotypic piece and then a big chunk of environmental noise, essentially. And so we establish then what that genomic correlation is, not only to the ultrasound, but also to the carcass trait again. And so we have to establish all those relationships among those pieces. There are places where the genomic association with the economic trait of interest, the carcass, is stronger than the ultrasound, and it comes in with a large heritability because you're looking at the genotype now and not a contemporary group deviation weighted by the heritability of the trait. I mean, so you've got some relationships there where the genomic piece can overpower that classic ultrasound relationship that's been predicting your marbling EPDs that you can see. And so you're going to see some animals that don't line up perfectly like your ultrasound contemporary group deviations. I mean, it's just the reality of it with the tests and the math that we describe. You have to have some assurance that we spend a sizable amount of time establishing conservatively what those relationships are between the genomic piece and the trait you're interested in for each in 10 to 20 sets of data, and establish what that correlation is before we turn the switch on. And likewise for the ultrasound. So they vary. Ultrasound has an impact on carcass, and there are places where the genomic piece overpowers that.
That's correct. Joe's question was management cannot change the genetic piece. Okay.
But it can be ultrasound.
Well, I think the key word that Sally used was environmental noise. Okay, and so I mean we've heard the classic from Angus breeders and all cattle breeders that use ultrasound through the years, thinking about, oh my God, how big the 205 day weight, or how much was his yearling weight, or oh my, he scanned 10% for IMF. Well, you know, I'm pretty good like Dad at picking out our own cattle, and actually the owner and partner of a very, very good bull by the name of U.S. Premium Beef, who was the first 10% IMF bull that we had ever identified. Now, I think if we had the tools that we have today, now he's a good bull for marbling, but he's not a great bull. He's probably top 25% or so. And so I think, Jimmy, the key is we take the environmental noise and we identify the genotypes. We still have to submit our phenotypes via ultrasound, being weights and measures, but then the genotypes are going to help us choose which ones to multiply correctly.
You know, with this young bull, and those genomic proj have value. And so on him being a non-parent, it would vary by trait, but you're going to get some bump on his accuracy just from those progeny being genotyped, even if he didn't have his own. Now, his own coming in only and the progeny never checked, that'd be one thing, but for those progeny being tested, you know, he could be at 0.3 or so. It varies on the trait, but it's counting towards him, and they can be more powerful than regular phenotypic progeny. And I really can't give you an exact estimate on 50 proj, but they have merit. They'll move the EPD. I think that's what we also see on these young animals, and whether it's initially non-parents and their EPDs move, like William described, but also, you know, young sires that already have phenotypic progeny and they acquire genomic progeny, that accuracy can sure bump up. I mean, gradually on sires right now that may have an accuracy of 0.4 or 0.5, they have a bunch of genomic prog come in, and you don't see a huge bump, but you will see that etch up, 200s, 300s, depending on how they're adding them. So we're watching them. We're kind of learning as we go on that too, Donald, as the data comes in.
That's how we were having this discussion a little bit earlier. Same thing. I mean, I don't think we're deep enough, into the data. The biology and the mathematics tell me it'd be a fairly steep slope of diminishing returns, though, because what we're trying to do in the absence of that sire's genotype is based on the genotype of the offspring to assess what it is, and it doesn't take an infinite amount of those to get it. Okay? So it's a great question. The data's going to share that with us, as we get further along here in the coming weeks.
Donald, I think we've all seen, and maybe, that's a great question, and I didn't understand it at first, so thank you for describing it. But, we think about those standards of the breed, those 0.9 accuracy bulls, and percentile-wise, they haven't changed dramatically, but they've changed more than we would have expected. And as I talk and try to learn and understand myself, well, they didn't have that much more data that came in, but they had that many more samples that came in. They had that many profiles coming in, and that really strengthened and locked in those proven bulls, whatever they were. That bumped them, to my layman's viewpoint, to where they are today. Because we've seen changes in those bulls that, frankly, I wouldn't have expected on a 0.9 bull. And so I think we see the power of those profiles, what that's doing, because of all the data that's being collected on their offspring.
There's probably a couple of three good, decent ways to illustrate this. You guys can probably think of, I know Mark can probably help me out on this, flushmate brothers that once are progeny proven or full sibs. Yeah, they just simply, full sibs. We can come up with examples that are today high accuracy bulls that are high birth weight and low birth weight out of the same flush. Exactly. I've actually, Bill, if you wanted to, I'm sure you could pull up a Stockman and Rancher slide, and that would be a great example. You got 10 seconds. But seriously, it's that exact same sort of thing. I don't want to stretch the bubble too far, but one of the things we're starting to get a lot of questions about are actually before embryos are even implanted. Can we go and assess that genetic variation that's there? And certainly if we can acquire enough DNA and keep an embryo alive or robust enough and suspended in time, we can certainly do that. Genomics aside, we see flushmates with genetic variation, and it picks up that genetic variation.
The data collection on the phenotypic piece, I know that the companies work on that individually right now to try to explore kind of the research component of health. We haven't carried that fully out, and we sure don't have a database. We struggle just to have a reproductive database that we want to grow. And so the health piece is way out there on another tier that we haven't explored.